Hello, yeah, in this video, I want to show you how to perform tilted bootstrap for a linear regression model. So basically, I'll have some R codes that generate a sample data set and perform a linear regression analysis. And then I'll show you how to do the tilted bootstrap for a targeted coefficient using the R package boot. The function is tilt.boot, okay, in the boot library. And also I will show you another R library called the tboot, specifically for tilted bootstrap. I will show you how to use that to do the tilted bootstrapping for specified marginal means for the coefficient, okay. All right, so let's specify a random seed with today's date. So sample size 100, x1, x2, y is a linear combination of x1, x2 plus this error term. Assemble them into a data set. So this is the data set, okay. And then load the library boot, and we write this reg underscore stat function, which is used to return regression coefficient. So this function ready in data and indices, and then we subset the data using the indices to pick the rows, and then we fit the regression model on this subset, and then we extract the coefficient. Okay, so all right, let's set another random seed, and then we do the bootstrap using the boot function. So boot of data statistical to reg underscore stat and r equal to 200. And we can take a look at this object. So it's quite complicated with a lot of things in there. It's not a focus here, so I continue to the tilted bootstrap using library boot. And we want to get the observed coefficient by fitting the linear regression model and extract the coefficient with the coef. And once we have the observed coefficient, we can actually specify which coefficient we want to tilt it toward. Okay, so this one, let's tilt it toward x1. So we write this function called, we write this code called tilt underscore out underscore x1. So tilt.boot, that's calling the function using the data equal to data statistical to reg underscore stat. And I think this r equal to 200, 200, style equal to I, tilt equal to true. And here, this is important, theta equal to observed and coefficient of 2. So that's, remember, we have y, x1, x2. So this x1 is the coefficient of 2. Okay. And we also says index equal to 2. And that it. For that, we generated the tilt out x1. Similarly, we can do it for the x2. The only difference is now we have theta equal to observed coef of 3, index equal to 3. Okay. So now we have the tilted result. We can print them out. This is the original, the observed coefficient. Remember that? So for x1, it's about 1.3856. And so this would be the bootstrap, the tilted bootstrap replicates. You look at the column 2, that's for the tilted bootstrap for estimating x1 coefficient. And remember, the observed one is 1.3856. So the bootstrap replicates are around 1.46, 1.3, 1.45, 1.47, 1.33, 1.455. So they're pretty close, okay? And similarly, there's some note. In this printed out matrix or data matrix, the first column is the intercept, second one is x1 coefficient, and third one is the x2 coefficient. And if you want to learn more about the structure of this object, tilt out x1, it also has a lot of stuff in it. Okay, and it's a 400. That replicate matrix is 400 rows, and we have the entire object. You can print them out. You can spend some time to read through the documents about what each component is about. Okay. Similarly for the x2. Okay, so this is the original one. X2, the coefficient of 1.94, and this is the tilted bootstrap replicates. We focus on the third column. So, okay, the original coefficient is negative 1.94. So the bootstrap replicates around negative 2.14, negative 1.82, negative 1.92, etc. So they're pretty close. Okay. All right. So we did the tilted bootstrap targeting one coefficient at a time. But the tilted bootstrap really is capable of targeting multiple coefficients simultaneously. So for that, we can use the tboot library. We can specify any means for both predictors. For example, x1 equals, say we want to tilt the means of x1 toward 3 and x2 toward 0. Okay, this is really made up. Okay, so in your data analysis, you may have other reasonable values. You want to tilt the coefficient toward 2, so you can specify them here. So this is just a demo. So specify the target means, then we need to calculate the tilted weights. So the tilted bootstrap is basically a weighted bootstrap. Okay, so we need to calculate the weights by using the t-weights function, so using the data and targeting the target underscore means. So we want to really tilt it toward the target means, get these tilted weights. And now we need to draw the tilted bootstrap sample from the computed weights using the tboot function, number of rows of the data, and weights equal to tw, the tilted weights, and data set equal to data. This is our bootstrap sample. We can examine the column mean of the bootstrap sample. You can see. So the original one, remember we were targeting x1 toward 3, and x2 is toward 0. So here we get the mean around 2.97, so which close to 3. And the mean of x2 is 0.12. It's a little bit off, but not too big deviation away from 0. So overall, the tilted bootstrap is pretty successful. Okay. All right. So this is a demonstration for showing how to perform tilted bootstrap on a linear regression model. Thanks for watching.